Hey, welcome back. My name's Charlie. This is my Tesla turbine combustion boiler steam powerhouse. Whatever you want to call it. The Tesla's patent GB186 I know it looks like there's a lot going on here. It's rather simple. For a quick reference, that's the patent I'm referring to. Fuel tank, compressor, air fuel mixer, combustion chamber, spark plug, accelerator nozzle, steam tube, steam combustion mixing tube goes into the turbine. The exhaust from the turbine goes through a boiler, makes more steam. That steam mixes with the exhaust products and goes in the turbine. It just keeps recouping as much as it can. So, how that relates to this. Along the bottom here, there's a combustion chamber. This is the air fuel mixer. There's a combustion chamber in the center of this little micro boiler or nano boiler, what do you want to call it? There's a spark plug that comes up and it'll come out to here for the wire to go in. The combustion chamber accelerates the products down the nozzle. That nozzle, this half-inch sleeves into the 1.5-inch tri-clamp tube that's on the inside of this 4-inch tri-clamp tube. That mixes as a venturi going through, and then that goes right up to the turbine. Now, so this essentially is a boiler with a riser, header. That steam that's produced from all of the heat loss that would be normally radiated off of the combustion chamber out into the air, all that heat, that's going to be collected just to boil water. What this will also do is keep any of the components in the combustion chamber from ever going too hot because they're submerged in water, essentially making a water jacket around it. So the steam that's produced from here comes up, header, that steam comes through here. I've got a mesh screen in there because of where this cap came from to help minimize as much of the water droplets from getting in there. The steam from that comes through here, drops down, mixes with the combustion to cool the combustion products right before going into the turbine to allowable temperatures with keeping all the same amount of energy available for expansion. This is a downcomer for any water droplets that do happen to make it through to fall back all the way through. Sight glass to see the water height. Also sight glass to see how the boiling is going on inside, if it's bubbling up too much, or if this screen's even helping. I wanted to be able to see that. The igniter electrical plugs will come in through here. We've got temperature, pressure, 30 psi max pressure relief, a blow off for a whistle. And I've got a really cool idea that I can't wait to show you guys, because I had the idea, because most steam boilers have like a whistle, go toot toot. And I was looking at whistles and I came across a pigeon call whistle. So in Tesla's honor, I'm going to be doing a pigeon call steam whistle. Go, whoo, whoo. Whoo, whoo, whoo. But got some extra back connections here if I want to add some more or have any other sensors or feed anything else I want into this. For the time being, I'm not going to pressurize this just because I don't want to deal with that. Secondly, I'm not sure how well or how much it'll pressurize, because I think the exhaust or the jet from the exhaust from the combustion will be pulling a vacuum on this, a venturi vacuum on this whole boiler in and of itself. So it might never even get over pressure unless it starts raising too much in temperature. But with a full 1.5-inch outlet available to go open to wherever the combustion products go to whatever pressure just before going into the turbine, it's a lot of flow area. But yeah, this is the shebang. Everything. For currently, I only have this set up to be able to do liquid fuels, just because this is the type of nozzle, and I'm not sure how well or how fast any kind of solid fuels are going to burn with such a small combustor that's on the inside there. I'll show you the actual combustion chamber. This is what that looks like. this is essentially what's right inside there. Got spark plug, inlet, combustion chamber, accelerator nozzle, and goes right out. Had to disassemble this guy a little bit to get some parts, but for the most part I got most of it over there still. I just needed to move it aside. But this is it. This is like, oh, this is the for all the money here, guys and girls. It doesn't get better than this. Like, this is the complete package. Full high temperature combustion plus steam with recouper with all of these heat exchangers that will also, so like all the exhaust from this will go in to power the vacuum steam system as well. So I didn't complete this secondary setup here where I wanted to sleeve the steam or the combustion jet steam thermocompressor. And if you're not sure what I'm talking about, the steam mixing tube, a thermocompressor is essentially an ejector or steam ejector, but this uses the combustion jet as an ejector to provide a vacuum on this and send them both into the turbine. So instead of having it just mixed out and open for this also, I put this so that it was also sleeved in another set of tubes. So all the heat that radiates away from the steam tube, the steam and the exhaust mixing tube before going to the turbine is then recouped inside of this 4-inch tri-clamp system. This is completely sealed, so in and out. And I'll be able to either submerge this, I'll have another in and out connection, through wall connection for this to go from outside into these 4-inch pipes and then into here. But so all of this will be sleeved in side of the vacuum chamber boiler. So all the heat loss from the steam or the exhaust steam thermocompressor or combustion jet steam thermocompressor, however you want to call it, all of the exhaust or all the heat radiated from that can be recouped into the vacuum boiler for the vacuum turbine. And it is a complete package with the vacuum system and the small combustion boiler steam turbine and a full stainless steel turbine that'll go on here and an aluminum one that goes in there. We will have all high temperature, high pressure, all the way down to low temperature, low pressure in one package. Soon to come and be available for all of you guys. Oh yeah, got a little boiler blowdown filler. Also, I didn't get a Hartford loop in this because I won't be refilling it straight loop style right now, but yeah, it's just like a little micro boiler. It's a little stout, little pot boiler or shell boiler. It's a little micro guy. It's a single pass flame tube micro boiler that the steam produced from that mixes with the combustion and then goes into the turbine. And then the exhaust from the turbine goes through other heat exchangers to produce more steam, either for mixing into this turbine or mixing into the separate turbine in a separate system. Let me know what you guys think. Does it look like it came from the future? Because it looks like that to me too. I really don't know what just kind of came on this table. Just kind of started assembling and it just aha'd to me. Just parts just seem to keep fitting together perfectly. The only thing that I'm having a difficulty with fitting together is this little area here, but I've already got an idea for working that out. Safety first, everyone. Safety starts with you, me, and we. Safety starts with we.